In this video, we'll be talking about capacitors. Since this is going to cover a bit more content, this topic will be split into two parts. Let's start off for what is a capacitor. A capacitor is an electrical component that stores energy, electrical energy. So the symbol you may see for them in your circuits, you'll see something like that. That's a capacitor. And with capacitors, we will need to know capacitance. Capacitance is defined as the ability of something to hold an electric charge. So this means bigger the capacitance, the bigger its ability to hold more charge. So a basic model of a capacitor is like so. It's one plate, that's one plate. And as you can see, it's just like our symbol there. So let's call this the positive side, this is the negative side of our capacitor plate. And we are going to draw a circuit here showing a battery connected to a capacitor and through a bulb. So I'm going to draw it here. I'm going to draw my bulb. I believe this is the symbol for a bulb. And down here, minus, plus. So we have our circuit here, and if you remember, electrons flow from the negative to the positive. So our electrons are flowing this way. And just a quick refresher, conventional current is the flow positive to negative. So the battery contains a surplus of electrons and they are flowing to the capacitor's negative terminal. Once they reach the negative plate, they stop due to no conductive path to follow across this capacitor. So we have our electrons just traveling through here. You know, there's going to be a buildup. It's going to be a buildup here. The electrons are coming in at this plate, you know, just building up. And you remember that they're attracted to the positive side. So we're going to have some coming over here. And this is going to briefly light up our bulb, just for a brief moment. So because it's moving about, you know, there's some being moved about. This battery is continuously pushing. It's pushing these electrons along and it's pulling them across here until each plate, so from each of these plates, until the plate becomes saturated and can no longer accept new charges. So when this happens, our briefly dim light bulb will stop. It's no longer lit up. And upon reaching saturation, the capacitor is said to be fully charged, and this charge here will equate to here, to how much it's been charged. So if this was a 9 volt, and this will be rated 9 volt. Assuming it's charged, and the capacitor can take up to 9 volts, because remember, everything has a rated voltage. So if that made sense and you understand that these electrons, they flow from the negative plate of the capacitor to the positive plate of the capacitor, and you understand once these two plates are like saturated, they can't get any more on, so it's full, then can no longer transfer. This is now at the rated voltage. What will happen if we remove our battery? So we remove our battery from our circuit and we attach a conductive wire. So we'll redraw our circuit. So we'll redraw a circuit here. So that's our capacitor. And that's our bulb. What do you think that will happen if this capacitor is fully charged? Here we go, plus, we go minus here. What do you think will happen? Well, if we if we do this, it will discharge this capacitor, as because it's acting as a voltage source. And again, for a brief moment, our light bulb will light up. Okay, so this is acting as a voltage source if we remove the other battery, and this bulb will light up, as they do hold voltage, charge I should say. Though, do be warned that because they can hold their charge, they can do so for many hours, and so do make sure that the capacitor is fully discharged before use. So to do this, we can attach a resistor across the capacitor's terminals and wait for at least around 45 seconds. Do make sure the capacitor is rated at least 1 watt, and in our previous video we knew what the watt was for power. So just going to get my capacitors here. Here I've got, this is how a capacitor looks like. So you can see we have a negative terminal here, and we have a positive one. This type of capacitor is called electrolytic. We can get many different ones. We can get ceramic based, we can get like actual ones, film ones. So this one's electrolytic, and these are sensitive to their polarity, hence why they've got a rated well, they have a rated voltage, and as well they have a negative and positive terminal. So the unit for capacitance is farad, which is F. I'll write it over here. That's our unit for capacitance. And so you know now that the capacitors give us the ability to store charge, and we can better use that charge in its energy, in its transfer of energy within our circuits, like what we did with the light bulb here. So you may see capacitors in their symbols like so. This is a polarized capacitor, where like the capacitor I just showed you, the electrolytic one, you need to take note of its polarity, the positive and negative. And the other symbol I showed you, it doesn't really matter which polarity you use. So this would be like your ceramic capacitors, they don't really have a polarity. You could just put them in any way. And yeah, so what are they used for? Well, we know for one, I'll just make a box here. They're useful for storing charge. And another few examples of their uses are for decoupling and coupling purposes. I'll just briefly explain that. Decoupling capacitor, otherwise known as a bypass capacitor, stores charge and provides power in case there's an input voltage drop to an integrated circuit, so an IC. And this is why in your circuit diagrams you may see them as close as possible to pins. This will be their voltage in pins, and this allows them to provide a nice steady voltage. So you may, I don't know, you may, let's say you have a, you know, this is your V in pin, and sometimes you see a capacitor like this. This is an example of a bypass capacitor. A coupling capacitor, so they're useful for bypass. Coupling capacitors. I say these like bypass, they're all like, there's no, you can't go online and like type in like bypass or whatever. They're just the names given to them, like their intended purpose. These can be used to block DC and let AC signals pass, which is something we will most likely discuss in the next part of this video as we get further in. I just want to keep this video brief to let you know what these capacitors could do and their usefulness. So these, like I said before, used to block DC and let AC pass. We'll go through it. And then And these capacitors can also used to make filters to pass and block certain frequencies depending on design requirements. So very useful in filter design, which is a whole other thing. But as you could imagine, like, I don't know, for example, maybe like noise, for maybe in the power supply, noise, for example, you don't want unwanted noise that may be very sensitive to your equipment. So you want to make sure you filter out that to maybe keep it as minimal as possible, or to let only like certain frequencies through, and we're making a radio or something like that. So they do have their purposes. So that was just a brief overview of capacitors. Next video we will get further into on the more technical aspect of them and how we can use them in our circuits. Right? Thank you for watching.